Hello everyone, welcome to my channel, the place where soothing stories gently guide you into a peaceful slumber. I know that after a long, tiring day, there's nothing better than relaxing your mind, closing your eyes, and letting an intriguing tale lead you into sweet dreams. Sleep is a treasure that helps us recharge, and today, I'm bringing you a mysterious and captivating story to help you unwind. In this episode, we'll dive into a secret buried deep beneath the earth. Kola Superdeep Borehole. What mystery did the Soviet Union bury for years? Join me as we plunge into this astonishing scientific journey, where unexpected discoveries and strange rumors await. Find a cozy spot, relax your body, and enjoy tonight's storytelling session. We know very little about the internal structure of Earth. For example, our planet is not perfectly spherical. Due to its rotation on its axis, it is slightly flattened at the poles. Consequently, Earth's equatorial diameter is 12,742 kilometers, which is 43 kilometers greater than the polar diameter, making the polar diameter 12,711 kilometers. Earth is the densest celestial body in the solar system, followed by Mercury among the planets. The inner layers of Earth, core, mantle, and crust, rotate at different speeds relative to one another. Oxygen accounts for approximately 50% of the mass of Earth's crust, existing in bonded forms within most minerals. About 25% of the crust is silicon, with the remainder consisting of other elements. The continental crust has an average thickness of 35 to 45 kilometers, but beneath large mountain ranges, it can reach up to 75 kilometers. The density of material at Earth's core reaches approximately 12,500 kilograms per cubic meter, and the pressure there is up to 3.7 million atmospheres. The Kola Superdeep Borehole project was initiated during the Cold War as the Soviet Union sought to compete with the United States in geological science, much like the space race. In 1960, the U.S. began Project Mohole, aiming to drill through the oceanic crust to reach the mantle, but it failed due to technical issues and budget constraints. The Soviet Union opted for a land-based project on the Kola Peninsula, where stable geology and ancient rocks offer the chance to gather data on Earth's formation history. This was not only a scientific expedition, but also a symbol of Soviet technological prowess. With an initial goal of reaching a depth of 15,000 meters to surpass all previous records, Soviet scientists faced unprecedented challenges, from developing drilling equipment capable of withstanding extreme pressure and temperature to securing massive funding during economically challenging times. To prepare for the project, the Soviet Union assembled a team of top geologists, engineers, and scientists from various research institutes. They conducted detailed seismic surveys to identify the optimal location in the Baltic Shield, where ancient Precambrian rocks could provide deep insights into Earth's history. The choice of the Kola Peninsula was not only based on its geology, but also its remote location, which helped limit international attention during the intense competition with the West. Scientists hoped this project would yield revolutionary discoveries, akin to the U.S. Apollo missions. Humans have dived to the depths of the ocean, flown to the moon, and even sent rovers to Mars. We have studied Earth's surface extensively, but, as is often the case, the most intriguing aspects lie deep beneath. Despite these depths being right under our feet, we know as little about them as we do about distant space. A large-scale expedition is necessary to probe even slightly into Earth's crust, akin to landing on the moon. Such projects have been undertaken, yielding astonishing data. It's time to explore what lies deep within the Earth. Is there life down there? And what fascinating discoveries have we made? Today, we will explore three of the most notable superdeep boreholes, the first projects aimed at reaching the limits of Earth's crust. What we found in these deepest boreholes throughout the history of subsurface exploration. Exploring the subsurface is not just a scientific endeavor, but a battle against nature. Super deep boreholes like Kola Superdeep require a combination of cutting-edge technology, patience, and vast financial resources. While commercial projects focus on finding oil or valuable minerals, scientific boreholes like Kola aim to answer fundamental questions about our planet. How was Earth formed? What can ancient rocks reveal about the past? And could life exist at depths where sunlight never reaches? Most boreholes are drilled for commercial purposes, searching for and extracting minerals. However, some boreholes are created purely for scientific research, and these are often the deepest. This makes sense, as studying the structure of Earth's crust often goes hand in hand with commercial extraction. Yet, to advance scientific knowledge, we must drill deeper, to places with no commercial value, driven solely by scientific curiosity. So far, humanity has only taken its first steps in studying the physics of Earth's deep layers. Even the deepest boreholes today have not reached the mantle, as Earth's continental crust is about 30 kilometers thick. It's easier to access the mantle from the ocean floor, where the crust is only about 5 kilometers thick. The U.S. Project Mohole attempted this in the 1960s, but failed to achieve its goals. More recently, in the early 2000s, Japan's Chiki project also made partial progress, but did not reach the mantle. As for reaching Earth's core, that remains science fiction. The outer core lies at a depth of about 2,900 kilometers, an almost unimaginable distance. For context, the International Space Station orbits Earth at an altitude of only about 400 kilometers. This means exploring deep space is far easier than reaching Earth's core. Although the Kola Superdeep is the deepest borehole, it only penetrates about 0.2% of Earth's radius, equivalent to scratching the surface of an apple. This project surpassed the depth of the Mariana Trench, approximately 11 kilometers below the sea surface, demonstrating humanity's ability to explore deeper underground than in the ocean. However, the greatest challenge is not depth, but the soaring temperatures and pressures, which cause equipment to fail and require advanced technologies like high-temperature resistant alloys. Scientists at Kola had to develop new methods to cope with these harsh conditions, including advanced cooling systems and geophysical sensors to monitor rock structures in real time. The legendary Kola Superdeep Borehole still holds a record as the deepest borehole on Earth, while also delivering astonishing discoveries. At a depth of 12,262 meters, it is the deepest borehole ever drilled by humans, and one of the few created solely for research purposes. Scientists aim to study Earth's oldest rocks and uncover the mysteries within. The Baltic Shield near the Kola Peninsula was chosen as the drilling site because it features ancient volcanic rocks up to 3 billion years old, while Earth itself is only about 4.5 billion years old. In other words, drilling deep into this ancient geological region allowed scientists to glimpse Earth's primordial past. The choice of the Baltic Shield was not arbitrary. It is one of the oldest geological regions on Earth, where Precambrian rocks were pushed close to the surface by tectonic activity billions of years ago. These rocks hold information about Earth's early environment, from chemical composition to formation conditions. Scientists hoped that by analyzing core samples from Kola, they could reconstruct the planet's geological history, including changes in climate, atmospheric composition, and even early signs of life. Drilling began on May 24th, 1970. After 4 years, the borehole reached a depth of 7,263 meters. Initially, the team used drilling equipment typically employed in the oil and gas industry. Later, they installed a turbine drilling system where only the drill bit rotates rather than the entire pipe column. This turbine, 46 meters long, ended with a drill bit 0.214 meters in diameter. The drill bit was ring-shaped, leaving an intact rock core in the center with a diameter of 0.06 meters. A core retrieval pipe ran through the turbine to bring up rock samples. The primary goal was to obtain these rock cores. The pipe column submerged in the borehole, along with drilling fluid, weighed approximately 200,000 kilograms, despite using special lightweight alloy pipes. If standard steel pipes were used, they would have broken under their own weight. Naturally, the deeper the drilling, the more incidents occurred. The drilling technology at Kola involved using a special drilling mud to cool and lubricate, while also preventing the borehole walls from collapsing. Soviet engineers developed heat-resistant diamond drill bits capable of cutting through hard granite. However, unexpectedly high temperatures caused the drilling fluid to boil, leading to multiple interruptions and frequent equipment replacements, costing millions of rubles. Additionally, drilling at such depths required technicians to work in extremely hazardous conditions, with risks of borehole collapse or sudden methane gas explosions. One of the greatest challenges was maintaining the borehole's integrity when passing through heterogeneous rock layers. Engineers had to design special casing systems to reinforce the borehole walls, preventing collapse under immense pressure. This system included layers of steel pipes and specialized cement pumped into the borehole to form a sturdy protective layer. However, incidents like rock fractures or blockages occurred frequently, requiring the team to constantly adjust drilling plans. The most severe accident occurred when the research team took a break to attend an international geological conference in Moscow. Upon returning to work on September 27, 1984, disaster struck. During the interruption, the borehole walls, not yet stabilized with cemented steel casing, deformed. When the team attempted to raise the drill column as usual, it became stuck and broke. A turbine drill bit and 5,000 meters of drill pipe were left underground. 5 years of work were lost. Nevertheless, the team pressed on. They made multiple drilling attempts, veering in different directions to bypass the stuck equipment, a common technique in deep drilling. However, difficulties and accidents persisted, and the team often hit dead ends. As a result, the borehole was not a single straight path, but a complex journey with multiple side branches, resembling a strange, giant planetary structure. It took another 6 years to reach a depth of 12,000 meters. By 1989, the maximum depth of 12,262 meters was achieved. The creation of side branches in the borehole involved a complex technique called directional drilling. Scientists use advanced sensors and positioning technology to adjust the drill bit's direction, avoiding damaged or unstable areas. Each side branch was drilled from a branching point, creating a complex underground network. This not only increased the difficulty, but also extended the time and costs, yet it was necessary to continue the project's progress after incidents like the 1984 pipe jam. Keep in mind that Earth's continental crust is up to 30 kilometers thick. Although the borehole exceeded 12 kilometers, a tremendous technical achievement at the time, it still didn't reach half the thickness of the crust, which is already very thin on a planetary scale, especially compared to the mantle below, which is nearly 3,000 kilometers thick. A series of subsequent incidents led many to lose hope of drilling deeper. At that point, nearly all technical capabilities had been exhausted. It felt as if Earth no longer wished to reveal its secrets. Consequently, drilling officially stopped in 1992. Although the initial goal of 15,000 meters was not achieved, reaching just over 12,000 meters, the Kola Superdeep project was still considered a resounding scientific success. After the Soviet Union's collapse in 1991, the project faced severe financial difficulties. Funding was cut, leading to the cessation of drilling in 1992 and the official closure in 1995. By 2008, the borehole was sealed with a metal cap to prevent accidents, and it has since become a tourist attraction, drawing scientists and curious visitors intrigued by the history of Soviet science. The rock samples from Kola were used in interdisciplinary studies, from geology to microbiology. They provided critical data for building models of the evolution of Earth's crust and helped scientists better understand tectonic processes that have shaped the planet's surface over billions of years. Some rock samples were even sent to international laboratories for comparison with data from other boreholes, such as the All-Shake borehole in Germany or the ICP in China. The researchers gathered invaluable information. Every few meters drilled revealed a new mineral layer, such as a copper-nickel deposit, at about 1,600 meters, which could be commercially viable. An even more remarkable discovery was a geochemical anomaly, a rock layer with a high gold content of up to 1 gram per metric ton. However, this layer was at a depth of 9,500 meters, making gold extraction impractical. Nevertheless, this find held significant scientific value. Beyond practical industrial data, scientists obtained groundbreaking insights into the actual structure of Earth's crust. Initial predictions about the borehole's geological profile were completely wrong. The structure thought to extend only to the first 5 kilometers actually reached 7 kilometers, followed by a low-density rock layer that surprised many. The basalt rock expected to appear at 7 kilometers was not found, even at 12 kilometers. Prior seismic surveys had suggested a transition from granite to harder basalt, where seismic reflections were strongest. In reality, the area consisted of less dense, fractured rocks from the Precambrian era. In other words, everything we thought we knew about those depths was incorrect. This discovery stunned scientists who hadn't anticipated it. These new findings forced the scientific community to reevaluate all data from other deep geophysical studies from an entirely new perspective. The discovery of Precambrian rocks changed previous seismic models, which assumed a more uniform crust structure. The fractured, less dense rock layers at great depths suggested more complex geological processes, possibly related to ancient meteorite impacts or volcanic activity. Data from Kola was used to refine geophysical models, improving the accuracy of predictions about Earth's deep structure. Another surprising discovery was the presence of liquid water at great depths, where high pressure would typically turn water into ice or vapor. Scientists found hot water flowing from rock fractures, rich in hydrogen and other gases, suggesting the existence of a deeper underground hydrological system than anticipated. This changed our understanding of Earth's water cycle and the potential for subsurface resources. This groundwater may also play a crucial role in supporting microbial life, opening a new field of research into subsurface ecology. However, retrieving rock samples from great depths was not always possible. For instance, the rock cores mentioned earlier, even those as hard as granite, could crumble due to sudden pressure changes when brought to the surface. As a result, scientists often had to slow the core retrieval process, sometimes taking days, to preserve samples intact. Another surprising factor was the temperature at great depths and its rate of increase. Initially, scientists predicted a temperature increase of about 11 degrees Celsius per kilometer. However, between 2.2 and 7.5 kilometers, the rate surged to 24 degrees Celsius per kilometer. Consequently, at 5 kilometers, the temperature was around 70 degrees Celsius, and at 12 kilometers, it reached 220 degrees Celsius, much higher than expected. The unexpectedly high temperatures not only pose challenges for drilling equipment, but also raise questions about the source of heat in the subsurface. Scientists suggested that this heat could come from the radioactive decay of elements like uranium and thorium in the rocks, or from tectonic plate friction. These findings helped reshape geothermal models, providing critical data for predicting volcanic and earthquake activity. An equally astonishing discovery was the detection of 14 types of fossilized microorganisms at depths thought incapable of supporting life. These rock layers were 2.8 billion years old. At greater depths, where sedimentary rocks were absent, researchers also found high concentrations of methane. These findings represent only a fraction of the remarkable discoveries from the Kola Superdeep Borehole accessible to the public. Beyond fossilized microorganisms, the rock samples contain traces of microscopic plankton from 6.4 kilometers below the surface, indicating that ancient life could survive in far harsher environments than previously thought. These findings supported theories of subsurface life and influenced extreme biology research, even suggesting the possibility of life on other planets like Mars. Scientists use isotopic analysis techniques to determine the age of these microorganisms, providing evidence of an ancient ecosystem entirely different from Earth's surface. The presence of methane at great depths also raised questions about its origin. Some scientists suggested it could be a product of geological processes, while others propose it might be linked to ancient biological activity. Data from Kola opened a new field of research into subsurface gases and their role in the global carbon cycle. Humanity must humbly acknowledge how little we know about the planet we inhabit. The Kola Superdeep Borehole also holds another record, the source of the most unfounded rumors. The most widespread legend claims that at a certain depth, microphones on the drilling equipment recorded eerie sounds not caused by machinery. A recording of these sounds was even shared online, leading to a conspiracy theory that scientists had drilled into hell. Once again, this is entirely fabricated and untrue. For those hearing this story for the first time, firstly, there were no microphones on the drilling equipment at the Kola Superdeep project, only sensors to detect environmental changes, unrelated to conventional audio recording. Secondly, a Finnish newspaper was a primary source of the urban legend about the Hell Rig, coincidentally published on April 1st, April Fool's Day. The well-to-hell rumor spread widely in the 1980s and 1990s, amplified by American media through radio and TV programs, and even referenced in films. However, Soviet scientists categorically debunked it emphasizing that the strange sounds were merely equipment noise or minor seismic activity, unrelated to anything supernatural. The rumor reflects humanity's fear of the unknown beneath the earth. It also demonstrates how mythical stories can spread rapidly in the information age, especially when tied to scientific mysteries. The spread of this rumor was further fueled by the political context of the Cold War, when the West often exaggerated or distorted Soviet achievements to create a negative image. Some analysts suggest the well-to-health story may have been amplified as part of a propaganda campaign to undermine the credibility of the Kola Superdeep project and instill fear about Soviet science. However, a peculiar incident at Kola Superdeep may have inspired these fabricated stories. One such event was a serious accident that occurred under mysterious circumstances. David Guberman, director of the Kola Superdeep Research and Production Center and a Soviet academic, provided the clearest description. In an interview, he stated, "When asked about this mysterious story at UNESCO, I didn't know how to respond. On one hand, it's clearly nonsense, but on the other, as an honest scientist, I couldn't say I knew exactly what happened. A strange sound was recorded, followed by an explosion. A few days later, when we returned to that depth, we found nothing unusual. Thus, things at Kola Superdeep were not as straightforward as one might think. This incident was thoroughly analyzed by scientists, with the hypothesis that the strange sound could have been caused by the sudden release of trapped methane gas in rock fractures, leading to a rapid pressure increase and a small explosion. However, due to the lack of advanced recording equipment at the time, no specific data confirmed this hypothesis. This incident added to the mysterious aura surrounding the project, making it a subject of thrilling tales. Who knows, by 1995, the project was shut down and the borehole was sealed. Perhaps the next generation of scientists will follow in Guberman's footsteps and uncover the truth. The legacy of Kola Superdeep endures in modern science, influencing projects like the International Continental Scientific Drilling Program, ICDP. Russia proposed reopening the borehole in 2020 for further research, but this has not yet occurred due to high costs. The project reminds us that exploring the subsurface is not just a technical challenge, but a lesson in perseverance and humility before nature. Lessons from Kola have been applied to other deep drilling projects worldwide, from Iceland to Japan, and continue to inspire young scientists to pursue the unresolved mysteries of our planet. Though no longer active, Kola Superdeep remains a symbol of humanity's scientific ambition. It shows that, while we may conquer space or the oceans, we are still at the threshold of understanding our own planet. The mysteries of Kola, from ancient rocks to signs of subsurface life, await future explorers to uncover. And so, we've explored the mystery of the Kola Superdeep Borehole together. A remarkable scientific journey with discoveries that change how we view our planet, alongside enigmatic tales that spark the imagination. I hope this story has brought you moments of relaxation, gently guiding your mind into a peaceful space, ready for a deep and restful sleep. Thank you for joining me in today's storytelling session. If you enjoyed it, don't forget to like, subscribe, and turn on the notification bell so you won't miss the next fascinating tale. Relax, close your eyes, and let beautiful dreams carry you away. Wishing you a peaceful night, and see you in the next episode.